So, to the end of figuring out a picture for inverse sine, I need a picture of sine, right? Which I think you all can now provide. So, anybody want to tell me where you start for a picture of sine?
Origin.
Okay. Start at 0, 0. Then what?
Put a 90 somewhere on the right.
Put a 90. Okay, so you're doing this in degrees.
Sure.
Okay.
Then make a quarter of a circle. Going up.
So incredibly not a quarter of a circle. It's flat on top, but right here it's slope y equals, or the slope of 1.
Sure.
Trust me.
That'll work.
Okay, so you make one of these little lumps, and then what?
We'll make 180. You go all the way on the right.
Go over to 180,
Comes back
make
down.
another one of these little lumps, right? And then what?
270.
Then it's the same thing upside down, like this.
90's at the bottom of the hump.
And this one is
270.
270,
And then the last one is
360.
and that's 360, and then this pattern continues, right? How about to the left?
Same thing, just opposite.
Same thing, right? So we get lumps like this way, right? Okay. Now, what's the problem with trying to take an inverse function of such a thing?
It doesn't pass the horizontal.
Yeah, this thing miserably fails the horizontal line test, right? You guys see that? So I drew a horizontal line, right? I'm going to hit like here, here, here. So what am I going to do? These are my problem. How many of those am I allowed to have? One. How many do I have right now? No way.
Well, infinite.
Yeah, I have infinitely many of these, right? Crap. I really need to do better than infinitely many. So what are you going to do?
Find the ones
Yeah.
negative 99.
We're going to do the same thing we did before, right? We're going to cut this thing off. So where's your most convenient spot to keep?
Next to the 0.
Yeah, kind of the area around 0 where you can get away with this thing, right? So around 0, I'm going to kind of spread out and ask, when's the first time I run into horizontal line problems?
90.
If I run this way, yeah, the top of that's going to be the last time I'm okay. You guys see that? So I'm going to, oops, that's not where I wanted. I'm going to fill in this top dot, right? And then truncate the rest. Okay? So now I'm not running into a horizontal line problem over there anymore. What have I lost? Yeah, this little thing doesn't know how to sine lots of stuff anymore. It really only knows how to sine things that go up to 90 degrees. You guys see that? So I'm just saying, hey, on this version of the sine function, you can't stick in all the angles. You can only go up to 90. Where can I go down to? Down to the bottom of this thing, right? Negative 90? Okay, so that's down here, right? So I have conveniently drawn on a piece of plexiglass that big. You guys all buy into this? And I need to cut off the black because I wanted that out there. So the orange bit is going to be my inverse function, right? And I need to flip over the line y equals x. Yeah? This is hard for me to do, but I'm going to do it now. So you grab the corners, right? And to flip over y equals x, you need to give yourself some space or hit yourself in the face with a corner. This thing. Okay, see that? And I clearly erased a little bit too much. Oops, wrong color. Oh god, needed an assistant. Oh no! Help! Like that. Stop. You guys see this? Okay, so here's your graph for what? What am I graphing with orange? Sine inverse. Okay. Now I better figure out my domains and ranges, right?
So,
You guys?
Range is all real numbers.
no.
So which one's which? The domain is smashing onto the x's or the y's? I really need a way to hold this. Somebody want to hold this for me? Thanks. Perfect. Thank you. Okay, so what's this point right here?
The top one?
Yeah. So my scales are obviously a little bit dark. That point in the black was what?
1.
It was 90,
90.
comma 1, right? So in the orange, after I flip the x and y axes, remember I flipped their scales too. So in the orange picture, that's the point, what? 1, comma 90. And apparently I'm doing this in degrees. You guys see that? Okay, so how about this point? Yeah, in the black. So in the black, that was negative 90, comma negative 1. And now after I flip things in the orange, what is it? Negative 1, comma negative 90. You guys see that? Okay. So smashing onto the orange, I want to say let's do the domain for sine inverse. So sine inverse is going to map negative 1 to 1. So it can take ratios between negative 1 and 1. That makes sense, right? It's an the output of the sine function is an opposite over the hypotenuse. They can't get. Ooh, do I have to close these?
Including, yeah, now you do.
Yeah, because I can get 1 out, right? When there's sines of 90 degrees, right?
Yeah.
So these need to be closed. So I'm taking the closed interval from -1 to 1. And what are my outputs? Perfect. Negative 90 to 90 in degree land, right? So this is sine inverse for degrees. Or in radian land, negative pi over 2 to pi over 2. Guys cool with that?
Swell.
And this thing takes, what kinds of things are these? Yeah, these are a ratio of what? Yeah, side length, specifically they're the opposite to the hypotenuse, right? And these guys, what are these? Yeah, those are angles. You guys see that? But I can't get all the angles out of it. I can only get the ones between -90 and 90. You guys cool with this? So again, there's one of those like, okay, if I do this sine to an angle and then I do the inverse sine, I don't necessarily get back to where I started. I get back to an angle that's between -90 and 90 that happens to have the same sine. You guys see that? And that's a sacrifice I had to make because of the horizontal line test. I can't get away from that. Cool? Questions, thanks?